Hello everyone, welcome to my YouTube channel. Remember our last video we talked about graph plotting, how to plot your graph, how to get best fit graph, how to get good scale, and how to title your graph. Today we'll be talking about equation transformation with y is equal to mx plus c, and this is a whole lot. Yeah, it's a whole lot. We'll be looking at so many equations here. I think I'll look at just 2 or 3. The rest, any equation you want me to look at, you drop it on the comment section. Okay, don't forget to like, subscribe, and share. Thank you. So let's dive in. Let's take, for example, we have the simple pendulum equation. Simple pendulum equation, we have something like c is equal to 2 pi square root of L all over G. Simple pendulum have 2 equations. This is one, and the other one we have C is equal to CLN. This is the second equation for simple pendulum. One you introduce log, the other one you not introduce log. I believe one is in your manual, the 2 is in your manual for practical physics. So we'll be looking at this and we'll be looking at this. I'll transform this equation to look like this. Remember, with the cases, you'll be able to transform this. Remember, one of the cases is y is equal to mx, meaning that it's passing through the origin. One of the law I derived is that once you see a positive or negative sign in an equation, it means that that equation must definitely has an intercept. It's either from the positive side or from the negative side. But once you don't see a positive or negative sign in an equation, that means it's going to pass through the origin, like this graph, like this equation here. So we want to make this equation look like this equation. We want to make this equation look like this equation. Note, you can't make this equation look like this if you don't know what you are plotting against what. So, simple pendulum, there's always one thing you are plotting against one thing. You are plotting this quantity L in centimeter against T in second square. So now you are making L subject of formula and making T stay in place of this X. Let's dive in. So therefore, solution. We have T is equal to 2 pi square root of L all over G. No, it's T, not T squared. And the first thing you do to make this L subject of formula, you square both sides, change your subject formula. And we did back there. Square both sides. If we square both sides, we'll have what? T squared is equal to this 2 here will cancel the square root, but it will affect the one outside the square root. So we have 4 pi squared, bracket open, L all over what? G. So my T squared is equal to, we open this bracket, 4 pi squared, L all over what? G. So remember, we are making L subject of formula. So we cross multiply. If we cross multiply, we'll be having 4 pi square L is equal to what? GT squared. So how do we make this guy stand alone? How do we make L, the quantity L, stand alone? We divide both sides by what? 4. Divide both sides by 4 pi square. If I divide both sides by 4 pi square, I'll cancel this. Then my L is equal to what? GT squared all over what? 4 pi squared. Yes, that's correct. Now, is this equation here? Let me call this equation star. Is equation star looking like this? Some of you might say yes, some of you might say no, it's not looking like. But the truth is that this equation is definitely looking like this. Let me show you how. So, we have something like L. Recall that this from this equation, this is y, this is x, and this is the slope passing through the origin. This is the slope m passing through the origin. Let's compare this. Remember, it was L against T squared. So if I compare this, my L is equal to my y, which is equal to what? My g all over 4 pi squared. All this is equal to my m. All this is equal to what? My m. All this is equal to my m. Dot t squared. My t squared is equal to what? My x. So we have made this equation, we have transformed this equation to y is equal to mx. We have transformed this equation to y is equal to what? Mx. So that's the best way to transform that equation. With this, we can get your g, because you'll be asked to find g in any mechanics experiment. You'll be asked to find g. So my g here, all over 4 pi squared, will be equal to what? M. M signify your what? Your slope. So that's how to transform equation to these equations here. That's how to transform equation to this equation. Let's look for another one, which is your experiment 3. For some people, it's experiment M9. For some people, it's experiment 1. So let's look at this equation here. Let's look at this equation. And so we should plot a graph of log t against log L. Log t against log L. And there's no log here. So what do you do first? You introduce log. If I introduce log, I'll have log t is equal to what? Log CLM. My log t here is equal to log rules to say log c plus what? Log LM. My log t be equal to what? Log c plus n log L. My log t here be equal to what? Let's transform this guy, because we are looking at this. We are looking like this. We are looking at this equation to look like this. So we have n log L plus what? Log c. So therefore, we have transformed this equation to look like this. There we have our vertical, which is the log t, is equal to y. My m is automatically my n here, which is the slope, dot what is my x? Log L plus c. So that's how to find the constant which we were asked in your experiment. Find the constant n and find the constant c. So you equate this guy to this guy, you equate this guy to this guy, you equate this guy to this guy. That's how to get that done. Now the next one, I think I'll treat one more. Then we call it a day. I'll treat one more. Now let's look at this equation. C is equal to, I think this is your experiment 4. C is equal to, in some textbook, is experiment M6. In some school, is experiment 4. In some school, is experiment M6. C is equal to 2 pi square root of h square plus k square all over gh. Yes, it was the graph of ht square against h square. Look up, take notes. It's a graph of ht square against h square. Now looking at this equation here is looking big, right? So we are going to use this, transform it to this, to get our k and to get our g. That's the constant they say you should find in your manual. So therefore, let's go. Solution. We have t is equal to, okay, we don't have more space. So let's square it from here. This is square and this is square. So therefore, my t square is equal to 4 pi square. Remember, this is affecting this one outside, then cancelling this one. So therefore, we open bracket h square plus k square, close bracket, all over what? GH. Remember, anything you are doing, ht square must be on its own. You must make ht square subject of formula. So what are we going to do here? We open bracket. C square is equal to 4 pi square h square plus 4 pi square k square, all over what? GH. Let's cross multiply. Let's cross multiply with our open bracket. We cross multiply, we have GH t square is equal to what? 4 pi square h square plus square k square. So remember, we want this to stand alone and we make it look like this so that we can find the constants g and k. K here means, in your manual, K here means radius of gyration. So we have, what are we dividing through? We're dividing through by g. So if I divide through by g, you see that this is looking like this now. So therefore, g is here. So if I say g t square is equal to, let me make this guy look like this automatically. So here will be 4 pi square, right? We have h square, which is the x. See, it's x. We have all over what? G. You can decide to make your g cover everything, no problem. You can decide to shift it. It's still the same thing. Plus 4 pi square k square all over what? G. Now, looking at this, have I transformed this equation to this? Yes, I've transformed this equation to this. And it's looking exactly like this. I will say this is our y, right? Equal to, this is our what? M. Everything here is M. Dot x, this is your x automatically, horizontal. Plus what? C. So everything here is what? C. So you equate this guy to this. Whatever you get at the intercept, you equate it to this. You substitute your g after finding it here to get your what? K. The last but not the least, we'll be looking at errors in graph. Error in graph. Now, this particular topic gives students a lot of issue. Like, gives students a lot of issue. And I'm going to try to simplify it small, or simplify it small for you to understand. But please understand, because I'll try my best to make sure you understand everything we are doing here. Now, the first thing, there are different types of law. There are different types of errors. You have, and you know that errors means uncertainty when plotting your graph. You have maximum error, standard error, personal error, error due to wrong assumption. But that is not what we'll be looking at today. We'll be looking at standard error in G. Please take notes. We're looking at standard error in G and error in slope. Error in slope. Now for this is the equation. SG is equal to W all over what? N. For this is the equation. For this is the equation. SE is equal to 4W all over what? N R. Yeah. So please take this. I think in your experiment 4, you'll be doing this. You'll be doing either this or this. So I'm going to list the meaning of all the parameters here. Now, for W is known as the vertical scatter. Vertical scatter. For R is known as the horizontal range. For N, number of plotted points. Number of plotted points. 4 is a constant. The same meaning here is the same meaning here. The same meaning here is the same meaning here. Now, I'm going to explain this to the best of my understanding, so that you will understand too. Now, If you are given a graph to solve and you are done with plotting and solving the graph, and they say find the error in G or find the standard error, depending on what they ask. So let me assume that we are given a question and they say find the what? Find the error in the slope. Let me assume that. Now, how do we find the error in slope? This is a graph of L in bracket open against what? T squared in bracket close. You know that this is passing through the origin, right? So let's draw it from the origin. You assume, let's assume a best fit graph for this. Let's say 1, 2, 3, moving. Now, this is how to find your W, vertical scatter. Please pay attention. Listen very, very carefully. Pay attention. So how do I find my W? Now, you see these points closer to the gradient line, and these points closer to the gradient line. That's what we use to find your vertical scatter. The number of plotted points is already here watching you. Let me say you have length to be what? 2, 4, 6, 8, 10. Number of plotted points is 1, 2, 3, 4, 5. So your number of plotted points is equal to 5. Do you understand? Now, we have range. What is your range? Whatever you got here, this is your horizontal range. This is your range. Whatever you got here, when solving for your slope, this is your what? Horizontal range. So let me say the slope here was, your slope here was what? Change in L, all over change in what? T squared. So this will be L2 minus L1 all over what? T squared 2 minus T squared 1. Now your slope is, your horizontal range is anything you have here, the value you have here, you substitute it and put here. So let me assume that my horizontal range is what? 3.2. Yes, 3.2 seconds squared, because it has a unit. Here has a unit, which is T squared, S squared. Yes. So we have now to get this, 4 is already constant, which watching us. Your W is what we want to get. Now, this point closer to the slope, is how we get our W. So let's say we pick a ruler, we draw, make sure it's straight, like the one close to like your gradient line. Let's pick another ruler, we draw, make sure you place it to this point. Now, another person might decide to pick from here to here. Now, any measurement you get from here, vertically, let me say here was 4, here was 6, and here was 8. So you say 8 minus 4, your W will be equal to 8 minus 4, therefore it will be what? 4. So that's how to get your W. Whatever you get here, it is a straight line. That's what you have here. So that's how to get your W. So if you don't know how to get this, you can't find this. And note, your error, both standard error or error in slope, must not be equal to or greater than 1. Anything equal to or greater than 1, your error is big. Therefore, this will be 0.9 is okay, 0.002, 0.4. Anything larger than or greater than, anything equal to or greater than 1 is very wrong. As in fact, just know that you're not plotting graph. Your error is bigger than the graph itself. So that is how to get your vertical scatter and to find your standard error in G and error in slope. Bracket open and close, gradient. So thanks for watching. See you in the next video. Don't forget to like, subscribe, and share.